Alright, next are some examples where we need to isolate the log first, but we're not to the point where we're going to be condensing log expression. So in this teacher model problem, we have negative 10 is multiplying our log in front, and the first thing that we want to do is isolate that log, kind of just like when we were solving exponential equations, we wanted to isolate that base. So let's look at the relationship there. It's being multiplied, so we want to divide both sides of the equation by negative 10. So rewriting that, we get log base 6 on x minus 4 is going to be equal to 3. We can rewrite this equation so that we don't have a log in it. We would just need to use our properties and think about how that is going to swap into an exponential equation. So 6 is our base, and then doing the log on something gives us our exponent. So that means that 3 is our exponent. So we have 6 to the third power is going to be equal to our argument, x minus 4. Simplifying that, we cube 6, which is going to be 216, and that is equal to x minus 4. Then our final step is just to remove the minus 4 with a add 4 to both sides, and that would give us 220 is equal to x for our final answer. So our last step of the problem is just to plug in this and check our work. So the main thing is that we just want to make sure that we don't have an extraneous solution, and that would occur when we plug in our number and it looks like we're taking the log of something that is negative or 0. So that argument piece, the thing we're doing on the thing that we're doing the log on, needs to be greater than 0, which it is. If we simplify this, we get negative 10 log base 6 on 216, and we actually just did that. So we know that the answer for here would be 3, and we know that 10 times 3 is going to be negative 30, so that checks out. In that second problem that we do, I would encourage you to pause the video and try it for yourself, and then play the video to check and make sure that you got it right. So starting with this, I don't need to condense the log because there's only one log statement, so I can kind of skip past this first part. It doesn't cancel out. That would be like if I had the same expression of log on both sides and they were equal, then I could just set the arguments equal to each other. So before we can rewrite this equation, what we need to do is isolate the log, and right now it's not isolated because there is this plus 2 being added on to the end. Now, there aren't parentheses around the argument here, but it's sort of implied, even though it's not written. The parentheses are around the negative 3p, and then since plus 2, that plus sign separates the 2 into a separate term, I know that that part is not part of the argument of the log, and that that's separate. So the argument is negative 3p, and that plus 2 is not part of the log. Now, if they wanted me to think that it was part of the argument of the log, then they would have put parentheses around it. But when we have multiplication, it's implied, and so that's why there's not parentheses around that negative 3p. So moving on, I want to isolate the log, so I'm going to subtract 2 from both sides. That would give me log base 8 on negative 3p equals 2. And then I want to think about getting rid of the log. How can we rewrite this so that I don't have log in my equation? Well, we know our base is 8, and doing the log on something gives us the exponent. So that tells me that 2 is our exponent. So 8 squared is going to equal negative 3p. Simplifying that, 8 squared is 64, and that's equal to negative 3p. And then our final step would be to divide by negative 3. So rewriting our expression, we get p is equal to 64 over 3, and that's negative. I'm going to just leave that in a fraction since that doesn't reduce. And then of course I would want to plug this in and just make sure that it is okay. So log base 8, especially when I have a negative, I just want to go back and check, make sure we're not doing the log on something that's less than 0. So negative 3 times negative 64 over 3 plus 2. So it looks like that's going to turn out to be okay because we have that negative times a negative inside that argument there, so we are not going to end up with an extraneous solution. And so that does check out. We get, actually, I don't need to write that log anymore, but we get 2 plus 2, and that is 4, so it checks out. The last slide in this section is the We Do Plus, so I'd encourage you to pause the video and try it for yourself and then play the video to check and make sure that you did it correctly. So we can skip past some of these guiding questions here because we don't have log in multiple places. So I don't need to worry about condensing and simplifying that. I do want to isolate the log here. I noticed that we have this multiply by 3 out in front of the log, and we could get rid of that first before we decide to rearrange this into an exponential equation. So that's actually what I'm going to do. I'm going to divide both sides of the equation by negative 3. That gives us log of a minus 9 equals negative 1. And now if you hadn't noticed, that log doesn't have a base written there, but actually there is a base. It's just implied 10 for the base. So anytime we don't have a number written there, it's 10. We just know that it's 10. So rearranging this into an exponential equation, we would get 10 as our base, negative 1 is our exponent, so I can put that there, and that's going to be equal to a minus 9. So for this next part, you're going to have to recall your properties of exponents. So when we have a negative exponent, we actually need to invert the number. So 10 to the negative 1 is actually 1/10, and that's equal to a minus 9. And then we can isolate a by adding 9 to both sides. So I get a equals 1/10 plus 9. I would need a common denominator in order to add those fractions, so I'm going to change 9 into tenths, so that'd be 90 tenths. So I end up getting a equals 91 tenths for my final answer. Then I just want to go back, plug it in, check it, make sure it's okay. So negative log of 91 tenths minus 9. Find out what that is, so I get negative 3 log of 1/10, and if we're in base 10 on that log, then I know that doing log base 10 on 1/10 will give me the exponent, which is -1, and 3 times -1 is +3, so looks like we got the right answer. So at this point, go ahead and move on to the you-do problems until you get to the next section, and there will be some more videos explaining how to condense when we have more than one log statement